A function, f of x, is said to be continuous at a point x equals a if three specific conditions are satisfied. First, the function must be defined at x equal a. That is, fa must exist. Second, the limit of the function as x approaches a, written as lim x to a fx, must exist. Third, the value of the function at that point must match the limit, so lim x to a fx equals fa. If all three hold, the graph is smooth at x equals a with no break. For a function f of x to be continuous at a point x equals a, it must first be defined there, meaning f of a must exist. This is the starting condition. If the function does not have a value at that point, perhaps due to division by zero or some restriction in its formula, then we cannot evaluate or analyze its behavior at that point. In such a case, the graph shows a hole or missing point at x equals a, and continuity cannot be discussed. Therefore, existence of f of a is essential for checking continuity. Real-life question. A water tank is being filled, and the water level ft in liters depends on time, t in minutes. At minute t equals 10, is the water level changing smoothly without interruption? To confirm, we check. 1. Is f10 defined? Was the water level recorded at minute 10? 2. Does lim t to 10 ft exist? Does the water level approach a specific value as time nears 10? 3. Does lim t to 10 f of t equals fn 10? Short solution. If all three are true, then the water level is continuous at t equals 10. It changed smoothly without any sudden jump or gap. A bakery sells bread, and the price per loaf, f of n, depends on the number of loaves bought, n. If a customer buys 10 loaves, they get a bulk discount, reducing the price from $500 to $400 per loaf. Is the pricing function continuous at n equals 10? Short solution. 1. F of 10 is defined 400 per loaf. 2. Lim n to 10 f of n equals 500 from values less than 10. 3. But lim n to 10 f of n any f10, so the pricing function is not continuous at n equals 10 not as tau. There's a sudden price jump discontinuity. Question. A cafeteria charges students based on the number of meals x they purchase in a week. The cost function f of x is defined as f of x, begin cases, 500x, and text for x, 5, 2000 text for x equals 5, 480x, and text for x, 0.5 cases. Is the function f of x continuous at all points? If not, identify where it is discontinuous and where it is continuous. Short solution. For x na 5 strarv, snar and x na 5 snavatar, the function behaves like a linear equation, so it's continuous in those regions. At x equals 5, f of 5 equals 2000, lim x to 5 squared f of x equals 500 times t equals 2500. X of x equals 480 times 5 equals 400. The left and right limits are not equal, and neither matches f of 5. Conclusion. F of x is discontinuous at x equals 5 sta due to a jump. It is continuous everywhere else.